The challenges of living in space create. Living in space presents a unique set of challenges that go beyond the technological marvel of reaching orbit. These challenges encompass physical, psychological, and logistical aspects that must be addressed to ensure the safety and well-being of astronauts. Here's a comprehensive overview of the main challenges faced by those who venture beyond Earth. 1. Microgravity and its effects on the human body. One of the most significant challenges of living in space is the impact of microgravity on the human body. In the absence of gravity, muscles and bones begin to weaken because they no longer bear the same weight they do on Earth. This can lead to muscle atrophy and bone density loss, conditions that are particularly concerning for long-term missions. Astronauts must engage in regular exercise to mitigate these effects, using specially designed equipment to simulate weight-bearing activities. Additionally, the fluids in the human body redistribute in microgravity, often causing space adaptation syndrome, which includes symptoms like nausea, dizziness, and headaches. Over time, these fluid shifts can also lead to changes in vision and increased pressure on the brain, known as space flight-associated neuroocular syndrome, SANS. 2. Radiation exposure. Space travelers are exposed to higher levels of cosmic radiation than they would be on Earth. The Earth's atmosphere and magnetic field protect us from much of this radiation. But in space, astronauts are vulnerable to radiation from the sun and cosmic rays. Long-term exposure can increase the risk of cancer and other health issues. Shielding spacecraft, monitoring radiation levels, and developing protective measures are critical to addressing this challenge. 3. Psychological and social challenges. Living in confined spaces with limited privacy and a small group of people for extended periods can be mentally taxing. Isolation from family and friends, the monotony of daily routines, and the high-stress environment can lead to psychological issues such as depression, anxiety, and interpersonal conflicts. NASA and other space agencies place a strong emphasis on crew selection and training, focusing on psychological resilience and teamwork skills. They also provide mental health support during missions. 4. Life support and sustainability. Maintaining a habitable environment in space requires careful management of air, water, and food. Spacecraft must be equipped with life support systems that provide a continuous supply of breathable air, clean water, and nutritious food. This involves recycling air and water as much as possible and carefully managing waste. For long-term missions, especially those to Mars or beyond, developing sustainable life support systems that minimize the need for resupply from Earth is crucial. 5. Spacecraft design and safety. Spacecraft must be designed to protect their occupants from the harsh environment of space, including temperature extremes, vacuum, and micrometeoroids. This requires robust engineering and regular maintenance. The International Space Station, ISS, for example, has multiple layers of shielding to protect against micrometeoroid impacts and a carefully controlled internal environment to maintain temperature and air quality. 6. Health monitoring and medical care. Providing adequate medical care in space is a complex challenge. The lack of gravity affects the function of medical equipment, and the crew's limited medical supplies and expertise can constrain treatment options. Telemedicine, where medical professionals on Earth provide guidance and support, is an important tool, but it has limitations. As missions extend further from Earth, ensuring comprehensive medical care becomes increasingly difficult. 7. Communication delays. For missions beyond Earth orbit, communication delays become a significant issue. For example, signals between Mars and Earth can take between 4 to 24 minutes one way, depending on the planet's positions. This delay complicates real-time communication and requires crews to be more autonomous in decision-making and problem-solving. 8. Resource management and resupply. Managing resources like food, water, and fuel is critical for the success of space missions. On the ISS, regular resupply missions bring necessary supplies from Earth. However, for missions to the Moon, Mars, or beyond, resupply from Earth will be less feasible. Developing technologies for in-situ resource utilization, such as extracting water from lunar or Martian soil, will be essential. 9. Space debris and collision risk. The growing amount of space debris poses a risk to both manned and unmanned spacecraft. Even small pieces of debris can cause significant damage due to their high velocity. Space agencies and companies are working on ways to track and mitigate the impact of space debris, but it remains a serious concern for the safety of space mission. Conclusion. Living in space is a complex endeavor that challenges our current technological and scientific capabilities. As humanity looks toward longer missions and the possibility of colonizing other planets, these challenges must be addressed with innovative solutions and robust planning. The experience and knowledge gained from missions to the ISS and beyond are laying the groundwork for a future where living in space could become a reality for more than just a select few.